I'm Anil Kumar, sharing with you a very good question on relating data points of a parabola with quadratic equation. The question here is, determine characteristics and equation of the parabola from given set of points. X and y, 5 points are given to us. For x value of minus 2, y is 60, for minus 1, 24, 0, 0, 1 minus 12, and 2 minus 12. To begin with, let's make a rough sketch of the parabola. So I'll make a sketch here and then kind of write on top of it. So let's say this is our x and y axis. So I'll make a rough sketch. We'll see approximate diagram of a parabola and then figure out the characteristics. We are given points as 0, 1, 2, minus 1, minus 2. On the y-axis, these are multiples of 12. So let's take this as minus 12, and let's say this is minus 24. So here we need to go up to 60. So I should actually go further up. So we need 1, 2, 3, 4, and say 5. Okay, that should work. So let me just extend this a bit more to take care of 60. Okay. So approximately the points should be at definitely origin, then 1 and minus 2, 12. So that comes to kind of here, and 2 and minus 12 is right there. On this side, minus 1, 24, okay, and minus 2, 60. So minus 2, 60 is, let us say, somewhere there. So joining these points, we do get a parabola. So somewhere in between, we have a turning point, right? So what we observe here is a very interesting thing, and that is these 2 points, as you note, their y values are same, right? Since their y values are same, let me just draw a line here. We have axis of symmetry right across, right? So axis of symmetry is in between these 2 points. So we can say, well, this is our axis of symmetry, right? So this information we actually get from the data itself. So that becomes axis of symmetry. Okay. Now we can find equation of this axis of symmetry by finding the average of 1 and 2, right? Center of these 2 points. Let's find that out. It will help us to sketch a parabola also. So let's find axis of symmetry. Which should be between 1 and 2. So average value 1 plus 2 divided by 2, right? Which is 3 over 2 or 1.5. So that is the value of x. So x equals to 1.5 is the axis of symmetry. Now once we know axis of symmetry, we know one more thing. That is, a parabola has even symmetry, right? So what is even symmetry? That is to say that it is symmetric about the axis, right? No, even symmetry means it is symmetric about the y-axis. Now it has moved. So it is, in this case, I should not write even symmetry because it has moved. It is symmetry about x equals to 1.5, since that is the axis of symmetry, right? So that really means that points get reflected. The most important point which we are looking into is the x-intercept itself. Since we have x-intercept at 0, axis of symmetry is 1.5, the other point should be same distance away, right? So that is to say that I should have another 0 which is same distance away. That means 1.5 from this place, right? So we expect the other x-intercept to be at 3. Do you see that? So from the symmetry about the axis of symmetry, we can find the second x-intercept. So we have another x-intercept at x equals to 3. Is that point clear to you? So we use this axisymmetry to figure out another point. That is to say, if I have 3 here for x, the y value should be 0. And I got this because of the symmetry about the axis of symmetry. Is that okay? So now I know that the parabola will turn, and I don't know from where, I don't know the y value, but I know that this parabola, which kind of comes down in this fashion, goes through these points, right? And then it has to go kind of like this. Do you see that? So that's the kind of parabola which we are looking into. As far other characteristics are concerned, we can always write down that it opens upwards, right? It has a minimum value. I mean absolute minimum value. Domain is always all real numbers. X belongs to real numbers. As far as the range is concerned, we'll be able to find the range only once we find the equation, right? So we'll wait for that time. End behavior, we can say as x approaches positive or negative infinity, y approaches positive infinity, correct? So these are the other characteristics which we can directly see from the graph and the information which we have on hand. Now let's try to figure out the equation, right? So let's work on the equation part now. Now since we have found that these are the two x-intercepts, we can write equation as y equals to a times x, the first x-intercept, times the other one, which is at x3, so x minus 3, right? So that gives us the equation. To find the value of a, we could use one of these points. Let it be 1 and minus 12. So minus 12 is the y value, so I'll put y as minus 12, a times x as 1 minus 3. So minus 12, a times that is minus 2. So the value of a is minus 12 divided by minus 2, and that is indeed equal to 6. So with a as 6, we have the equation as 6x times x minus 3, correct? So that is the equation. So now we can write down the equation as let me write down here itself. So the equation is y equals to a is 6 for us. So 6x times x minus 3. So 6x square minus 18x. You could write like that also, right? So that is the equation. Now once we know the equation, we can find the vertex. Since we know the vertex is at 1.5, so substituting 1.5 will help us to get exact value of vertex, right? So let's find the vertex from here. So the vertex is y equals to 6 times 1.5, which is axisymmetry, times 1.5 minus 3, and that is equals to, let's calculate, 6 times 1.5 times 1.5, and of course a negative value, so we'll just write this as negative 13.5. So that is negative 13.5. So when you multiply, you get negative 13.5, so slightly below minus 12. So the vertex here is at 1.5 is the x value and minus 13.5. So now we can write down that The vertex is, we can write further characteristics here. So vertex is actually at 1.5 minus 13.5, and range is y belongs to real numbers, where y is greater than or equal to minus 13.5. Is it okay? So we have minimum, absolute minimum, whose value is minus 13.5. So we know that absolute minimum value. So likewise, we can now get most of the characteristics from the given data. I hope that helps. And I hope you appreciate the technique which we used here to find the second x-intercept. That really helped us to cut down on a lot of steps. Otherwise, we would have been working with 3 different points and solving 3 equations. I'm Anil Kumar, and I hope that helps. Thank you, and all the best.